Hello everyone, welcome to our official YouTube channel of Hasmukh Goswami College of Engineering. I Professor Srinath Karli from Civil Engineering Department. Today going to cover the topic role of digitalization in construction industry, which is the part of the subject building construction. Role of digitalization is what all these methods are included in the construction industry. First one is prefabrication, or and we can say as in modular construction. Modular is actually prefabricated materials or some blocks or any components of a building which are constructed in a industries. So it is brought to the construction site and it is directly fitted into the specifically parts in the building and its components. Advanced in building materials, 3D printing technology, big data and predictive analysis, augmented reality, 3D scanning and photogrammetry, building information model, and advanced construction. These are all included in a role of digitalization in construction industry. At most in this generation, it is very important part. We have to learn, and we are going to learn this digitalization part in this presentation. Flow of presentation, I will include these topics and flow of contents, table of contents like foundation, substructure, what is 3D printing, what is augmented reality, photogrammetric, and some other references for this all topics. Foundation. So earlier in 20th century, we are having two types of foundation: shallow foundation and deep foundation. So deep foundation is that type of foundation in which earth moves down from the surface than the shallow foundation, and piling is done vertically for the for the deep foundation, and piles are driven into the drilled surface into the ground. So deep foundation, I can give you example of a Marina Torch, a skyscraper in Dubai. This is a Marina Torch in which they have used a pile foundation. In many buildings, it is not the same case that we are having a skyscrapers only we can use the pile foundations. For a building which is having a 3 to 4 floors building, we can use pile foundation also for the particular type of soil. So in the 21st century, rotary board piling and are driven into the rigs. So setting up of a rig, and second one is driving and casing insertion. Then after they are inserting the steel reinforcement. So steel reinforcement insertion, again they are pouring the concrete with the tremie pipe and casting. So last one is they are giving the casing retraction. After that the pile is casted, particular pile is casted. This is the method of boring pile. So here pile and pile cap. So this one is a column and a concrete pile cap provided for the support of every driven pile. The bottom is an piles driven deep into the ground, and after the number of we can observe that in PPT there are 6 piles. So that are all pile driven with the head is called an concrete pile cap, which is heavily reinforcement, and in that reinforced pile we can use the column for the superstructure of the building. This is an substructure. So substructure, in 20th century, the substructure of a bridge comprises of piers, abutments and foundations. These portions usually consist of machinery in some form, including the general headstone brickwork and concrete. Occasionally metalwork and woodwork is also used for the intermediate piers. So when girders form the superstructure, the resultant pressure on the pier or abutments is vertical, and the dimension of this simply regulated by the sufficiency of bear this vertical load. We can see this example: classical formwork method for piers. So piers are the abutments. Actually, abutments are the end portions of the bridge, and piers are the middle portions of the bridge. So it is used for the support of the bridge. So again, example of classical formwork method for pier capping. Second, so single span bridges have abutments at each end which support the bridge. Of course, abutments are very important in cable stay bridge also to resist the lateral movement of the earthen field for the bridge approach. Multi-span bridges require piers to support the end of the span between these abutments. So take an example, when there is a bridge, we are crossing the bridge. So at the both the end portion there are abutments, and at middle portions for the support of the bridge they are providing the piers. So what the example of abutments and pier very clearly. So in cold climates, the upstream edge of the pier may include a stark water to prevent accumulation of broken ice during peak snow melt flows. So in a colder regions where there is a accumulation of snow, the piers are actually protecting the bridge. So likewise, they are designed in that way that when the accumulation of snow is moving gradually, the pier actually breaks the snow part, and thus protects the bridge in the colder regions. The stark water has a sharpened upstream edge, sometimes called as an cut water. It is also called as cut water. This is an example, good example of a segmental pier and pier cap. Yes, of course, this is a prefabricated, and it is already casted in some industries, and it is having some formwork, good formwork. So now coming back to superstructure. The girder bridge is a bridge that uses girders as a means of supporting its deck. So whatever the deck is supported to any form, it is called an girder. Most common types of modern steel girders are plate and box. The girder is oftenly used interchangeably with beam in reference to bridge design. However, some authors define beam bridges slightly different from the girder bridges. So example of a classical slab stagging formwork. You can see this formwork. In 21st century, the support towers may be built segmentally. Often this is accomplished by the slip form construction. This you are observing the vertical form is a slip form construction technique. So where the false work moves upward following the sequential concrete pours. The false work uses the newly constructed concrete as the basis of a moving upward. After the towers are built, a superstructure is built atop the towers. This superstructure serves as a launching point for the building of the deck. It is also, the slip formwork is also known as scaffolding. Scaffolding are usually in the form of an bamboos or wood. The deck is now constructed sequentially, beginning at the tower at one section at a time. These are vertically erected. The process is usually accomplished using a self-propelled bridge layer and hoist the bridge section into a piece. Again, the cast-in bridges, the false work is connected to the previously installed concrete and allowed to cantilever freely. In precast bridges, what happens is that the concrete segment is constructed on the ground and transported and hoisted into that place where is to be the bridge is actually is to be placed or constructed. As the new segment is suspended in place by the crane, workers install steel reinforcement that attach the new segment to the preceding segments. What happens that when we bring the precast block or precast bridges into the site of the installation, it is placed by the crane and it is placed by the workers, and exactly they install that particular block in the particular segment of the bridge. Each segment of the bridge is designed to accept connections from both preceding and succeeding segments. So segments are actually a preformed or precast works. It is usually casted in the industries, and of course they are given some numbers so that It is exactly, I said, it is preceding, and there are some preceding segments and there are some succeeding segments. Each segment are given some serial numbers. So exactly that serial numbers is placed to form any type of an bridges or any type of an construction. You can see this segmental and PSC girder casting yard. Next is launcher crane for segment structure erection. Now coming back to 3D printing, as I've said that 3D printing construction, 3D printing also came in the construction industry. This construction printing refers to this called in 3D CP, refers to various technologies that use 3D printing as a core method to fabricate buildings and construction component. Many components of the building are also fabricated with various other materials. I will teach you what are the materials used in the 3D printing. Alternative terms are also used as an additive construction. Why additive construction? Because the prefabricated what we are using in a 3D construction blocks is actually added to the construction. So some components which are complicated to make on site are actually casted or it is 3D printed. Examples, main methods are extrusion, like we are having materials like concrete, cement, wax, form, polymers, powder bonding, polymer bonding, reactive bonding, sintering and additive welding. 3D printing at a construction scale will have a wide variety of applications with the private, commercial and industrial and also public sectors. You can see this example of 3D printing. This beam is placed in a actually constructed in a 3D. Now augmented reality, it is an interactive experience of real world environment where the objects are reside in the real world are enhanced by the computer generated perceptual information. What happens that we cannot visualize the original site or we cannot observe the reality. So for that thing, some sensor modalities including visuals, auditory and haptic, sensory and olfactory are also used. This augogram is a computer generated image that is used to create an AR. AR is nothing but when you don't have to visit the construction site or a construction bridge, anything real world environment. By sitting at your own place or an office, you can view the what it is going to be observed at particular construction site in a real form. It is autography or augogram is an science and practice of making angiograms for AR. AR can be defined as a system that fulfills three basic features. First one is a combination of real and virtual worlds. Real world and virtual world, it combines to form a good image, real-time interaction and accurate 3D registration of virtual and real objects. So this technology 3D printing is different from the augmented reality. So here this is beam is casted in a 3D printing machine and various other building components are also casted in 3D printing machines, but augmented reality is different. See, this is a good example of, you can view the office building, shopping center, apartment buildings, etc. So augmented reality is different from 3D printing and of course photogrammetry. We can define photogrammetry as an art, science, technology of obtaining reliable information about physical objects and the environment. The process through the process of recording, measuring and interpreting photographic images and patterns of an electromagnetic radiant imaginary and other phenomenon. In simple terms, we are using photographic images, we are using electromagnetic rays to observe the zero error of a ground phenomenon and other examples of a phenomenon. So electromagnetic waves are used for the topographic mapping. We are actually going for the mapping. Mapping is something like what we are observing the ground, how ground gradients are. The gradients is actually up and down of the ground. So how we are observing the topographic mapping through the photogrammetric method is like something we are observing the ground in a photographic way, in a graphical point of view. We can see that. I will show you the examples. So it's very good in engineering, architecture, quality control, this method, and every, of course, police investigation and geology, and last one is topographic mapping. For example, you are going to construct a new railway line. So in a new railway line, you of course the major part is to the place the railway line in center line position. To place the railway in center line position, topographic mapping is important, and this archaeologist, everybody quickly produce the plan, and the photographic image is used as a graphical image to present that railway line in a center position in the real grounds, in a real field. So it is quickly produce plans of large and complex sites. Meteorologists use it to determine the wind speed of tornadoes when objective weather data cannot be obtained. Flying height, yes, this is an example of an photogrammetric measurement. The flying height measures the altitude and height of the ground object. You can see this example. So after observing the photogrammetric in real scale, like measuring in from this instrument, we are having one good example of an photogrammetric measurement is LIDAR, light detection and ranging. We will discuss in the next chapter and next lecture. But after the LIDAR, the thing is not completed. LIDAR observes the ground reality and height and width of the grounds and buildings and industries, everything. But we have to process that information into some software. That is called an photogrammetric measurements. So here we can also see the building site, building ground level and construction level, and after that we can plan some kind of an building or any type of an structure, transportation structures or any kind of an, by using this example and by using this virtual example. Recent technologies in construction industries. We are moving towards the recent technologies like they are having machinery for a parapet wall, power curber machine for building a parapet wall in between. It is also used in the curbs also. The direct casting of a parapet wall, yes, of course, this machinery can also be used in the curbs for the road construction. Median casting machine is generally observed in roundabouts, intersections, and some places where median is used actually. And of course, median is what we can say in general terms is divider. It is not as said as in divider, never. It is a median in between the road. The road is divided, the median divides the road. That's why it's called a median. The actual term is a median, which we call in general term, in social terms, as a divider. But it's a wrong term. In our specifically in technical line, we are saying as a median. The median we call as an the median divides the road into two parts in different lanes. So for casting the median, this machine power grabber is used. Again, R.C.C road laying machine is also used for the construction of an R.C.C road, reinforcement concrete road. Next one is transit boom placer. This transit boom can approximately place the concrete from a ground level up to 60 meters height and more than the 60 meters height. So it is a very good, having a very good capacity. and it is an hassle-free also to transport the concrete at any cubic meter or any amount of concrete from ground level to any of the upper levels. Concrete floater. Concrete floater is used to level up the slab surface or any of the wall or parapet wall or a slab surface floater. These are my references in which I have taken all this content. So hope you enjoyed my video, and if you like my video, like, share and subscribe. Thank you for your attention. Thank you very much.